When a certain medical drug is administered to a patient, the number of milligrams remaining in the patient's bloodstream after T hours is modeled by D of T equals 60 times e to the negative 0.2 T. How many milligrams of the drug remain in the patient's bloodstream after 3 hours? So we are wanting to compute D of 3. And we're going to round the answer to 1 decimal place. So we are going to enter in the graphing calculator 60 second ln for the e to the x function, negative 0.2 times 3, since 3 is the value of t we've been given, close the parentheses for the exponent, and hit enter. And we get 32.9 milligrams. So now let's go down to the next question. Doctors use radioactive iodine as a tracer in diagnosing certain thyroid gland disorders. This type of iodine decays in such a way that the mass remaining after T days is given by the function m of t equals 2 times e to the negative 0.087 z, where where m of t is measured in grams. Find the mass at time 0. So we would be evaluating m of 0, which would be 2 times e, and then the exponent would be negative 0.087 times 0, so the exponent would be 0. Since e to the 0 is 1, the initial mass is 2 grams. How much of the mass remains after 3 days? So we will be computing m of 3. And when we do that this time, we will have 2 times second ln, and this time negative 0.087 times 3 for 3 days. Close the parentheses for the exponent, enter, and we get 1.541 grams. So 1.541 grams. In our next example, we have the problem. A 30-gallon barrel is filled completely with pure water. Salt water with a concentration of 0.3 pounds per gallon is then pumped into the barrel, and the resulting mixture overflows at the same rate. The amount of salt in the barrel at time t is given by Q of t equals 9 times 1 minus e to the negative 0.04 t. where T is measured in minutes and Q of T is measured in pounds. How much salt is in the barrel after 4 minutes? And so we're going to be looking at Q of 4 this time. And so it will be 9 times, open the parentheses, 1 subtract second ln negative 0.04 times 4 because our T is 4. Close the parentheses, enter. And we get 1.33 to 2 decimal positions. So 1.33 pounds. How much salt is in the barrel after 8 minutes? We'd have Q of 8 equals, bring up the calculator again. This time I'm going to enter second, enter, to pull up the expression. I'm going to go back to and enter 8. And I noticed that I should have had 2 sets of parentheses at the end, one to close the exponent and one to close the multiplication. So when I hit enter this time, I get 2.46 pounds. Now we're asked to draw the graph of the function, and notice that our function, let's write it down again, Q of T equals 9 times 1 minus e to the negative 0.04 t. So if we think about starting with the function y equals e to the t, I'm then going to replace the t by negative 0.04 t. Then I'm going to take the opposite of that, so the opposite of e to the negative 0.04 t. I'm going to add 1 to that. And lastly, I'm going to multiply the result by 9. So first of all, we reflect over the y-axis and we actually stretch horizontally by a factor of the reciprocal of 0.04. Then we take the opposite of that expression, so we're going to go across the x-axis. We're going to add 1. That means we're going to go up 1. And we're going to multiply by 9. So we're going to stretch vertically by a factor of 9. So we start with 0, 1 as the y-intercept. We're going to still have 0, 1 after we reflect across the y-axis. We'll have 0, negative 1 after reflecting over the x-axis. We'll move up 1, which is going to move the horizontal asymptote up to y equals 1, but is also going to move 0, negative 1 up to the origin. So now the curve goes through the origin. Then when we multiply by 9, it's going to stretch vertically by a factor of 9. The 0.00 will remain where it is. But the rest of the graph will be pulled upward. There is also actually part of the graph is still in the third quadrant, but the part that we're interested in is in the first quadrant. So it appears as if when t gets very large, the number of grams is approaching 9, or number of pounds is approaching 9 pounds. Just as a check, notice that if we found f of 100, or in this case it's q of 100, that we would have 9 times minus e to the negative 0.04 times 100, which would be negative 4 plus 1. And if we compute that, I'll use second enter. I'll back up 3 and enter 100. 2 left parentheses, enter. We get 8.8 pounds. And so saying that it is approaching 9 pounds does seem legitimate, because after 100 minutes there would already be 8.8 pounds.